Good evening, Ajay.
Good evening, sir.
Good evening, sir. You can start now, sir.
Where we stopped last class, Ajay? Any idea? I think, yeah, this is tetraethyl lead I was talking about.
Yes, sir.
Tetraethyl lead.
Yes,
Yeah.
sir. Yes, sir. So you have to do that reaction with lithium, sir.
Lithium, yeah, we'll start from lithium and we'll continue with other topics today. All right. Now, we're talking about the topic, chapter is alkyl halides. We are learning the reactions of alkyl halides. Aryl halides, we will come back a little later. Now, we have to learn two important questions. I will teach you that important questions possibly today, if we get time, or else in the following classes. Now, reaction of alkyl halide with lithium. Alkyl halides react with lithium in dry ether to form alkyl lithium. It is very simple. Now, alkyl halides C2H5Br, ethyl bromide, bromoethane. When this is allowed to react with 2 lithium, 2 moles, 1 mole of alkyl halide requires 2 moles of lithium. So I will write 2 moles of lithium to be Li and Li. What happens now? This Li and Br gets eliminated as LiBr. In place of Br, the second lithium goes. So you get C2H5 Li. So it will be called as ethyl lithium. It's named as alkyl lithium. So in specific, it will be called as ethyl lithium. So this ethyl lithium is also an example for organometallic compounds. What is organometallic compounds? Metal, when it is directly bonded to the carbon atom of the organic group, then it is called as organometallic compound. So here you can see lithium is bonded to carbon. Now, if I have to write the structure of this, the structure of this will be CH3, CH2, and what? Eli. So lithium is directly bonded to the carbon atom. Therefore, this is also an example for organometallic compounds. Now, alkyl lithiums are similar in properties with Grignard reagent. Alkyl lithiums are similar properties with Grignard reagent. We learned Grignard reagent as RMGX. Now, Grignard reagent is the reagent which is used to prepare all organic compounds I told you. Similarly, alkyl lithiums also have the same properties as Grignard reagent. Now, these are reactive reagents also. These are reactive reagents. What do you mean by these are reactive reagents? Alkyl lithiums are reactive reagents. Now, coming to Friedel-Crafts reaction. Now, Friedel-Crafts reaction is the reaction between benzene and alkyl halides. Reaction between benzene and alkyl halides. Now, if you take a benzene molecule like this, tell me which is ortho and para position here. I'm numbering the carbon atom as 1, 2, 3, 4, 5, and 6. Tell me which is ortho and which is para here.
The first is ortho,
First is ortho, fourth is
para.
Para. Okay. Now, in case of pure benzene, all hydrogen atom will behave similar. Since all hydrogen atom behaves similar, there won't be any ortho and para positions. Now, only in case of substituted benzenes, we will talk about ortho and para positions. So in pure benzene, all hydrogen atom will have identical properties. Therefore, no ortho and para. Now, this is a substituted benzene. In place of hydrogen, we have substituted X. Now, carbon atom adjacent to carbon containing the functional substituent is called as ortho. Carbon atom adjacent to the carbon containing the substituent. So second position, second carbon is very close to the first carbon atom because the first carbon atom contains the substituent. Likewise, sixth carbon atom will be also called as ortho. Next to ortho will be meta, that is third and the fifth position, and fourth position will be para. So only in case of substituted benzene, what we talk about is ortho, para, and meta. In pure benzene, we cannot talk about ortho, para, and meta because in pure benzene, all the hydrogen atom behaves identical. What's the name of this molecule? What's the name of this molecule?
So benzene.
Benzene.
What is the name of this molecule?
So it's still benzene.
It is benzene because all hydrogen atoms are behaving same. So I've just shown one hydrogen atom here. When this hydrogen benzene is allowed to react with alkyl halides. Now, any alkyl halide we can take. The simplest alkyl possible is C2H5Br in the presence of anhydrous aluminum chloride. Remember, the catalyst used in Friedel-Crafts reaction is anhydrous aluminum chloride. Now, I can say this H and Br gets eliminated as HBr. In place of H, C2H5 goes. So you get a benzene ring and you get C2H5. This will be called as alkyl benzene. In specific, it will be called as ethyl benzene. It is called as ethyl benzene. This is called as Friedel-Crafts reaction. Important question for 2 marks. Explain Friedel-Crafts reaction. So what you should write, when benzene is allowed to react with or heated with alkyl halides like ethyl bromide in the presence of aluminum chloride or aluminum bromide catalyst, what we get is you get alkyl benzene. So when we're talking about bromides, the catalyst is aluminum bromide. And if you're talking about chlorine, then the catalyst is aluminum chloride. So aluminum chloride, aluminum bromide can be used. Right, the next one is substitution reaction. That is called as halogenation. Alkyl halides undergo further halogenation in the presence of sunlight, heat energy or peroxides. So this is ethyl bromide. When it's allowed to react with bromine, ethyl bromide, we can write like this for our understanding. We can write ethyl bromide. This, when you brominate in the presence Br2, in the presence of what is sunlight, what happens? This is hydrogen, sorry. One of the hydrogen gets eliminated and as hydrogen bromide, in place of that hydrogen, one more bromine goes. So you get C2H4Br2. Similarly, bromination, all the hydrogen can be substituted. That's what they say, reaction goes on, C2H3Br3. Did you follow? This is called a substitution reaction because one of the hydrogen is substituted by bromine. Followed with this?
Yes,
Followed
sir.
with this, yeah. Now, coming to a few of the questions, and then we will start with the mechanisms of the topic. Now, cyanide ion acts as an ambidentate nucleophile from which, what is ambidentate nucleophile? What do you mean by ambidentate ligands? Ligands which have more than one donor atom is called as ambidentate ligand. So cyanide ion is an ambidentate ligand. Why? In case of cyanide ion, nitrogen can be a donor atom or carbon can be a donor atom or nitrogen can be a donor atom. Since we have 2 donor atoms, it will be called as ambidentate ligand. But here in this case, cyanide ion is also acting as ambidentate nucleophile. Electron-rich groups are called as nucleophile. Now, from which end it acts as a stronger nucleophile in aqueous medium? From which end it acts as a stronger nucleophile than in nucleophile in aqueous medium? Now, the understanding is this. If I have an alkyl group is R, RNC, isocyanides, and RCN. This is called as cyanides or nitriles. Cyanides or nitriles. It's also called as nitriles. They're asking which is a stronger, from which end it acts as a stronger. Remember, in case of isocyanides, the bond is between carbon and nitrogen. So R group contains alkyl groups. R is alkyl, carbon, nitrogen. Now RC and cyanides, the bonding is between carbon and carbon. Are you able to understand this? So carbon and carbon bond is stronger than carbon and nitrogen bond. Since carbon and carbon bond is stronger than carbon and nitrogen bond, so the question is from which end it acts as a stronger nucleophile? From the carbon end, it acts as a stronger nucleophile. So the answer for this question is it acts as a stronger nucleophile from carbon end because carbon-carbon bond is stronger compared to carbon-nitrogen bond. The second question is, Identify the product A and B in this reaction. Identify the product A and B in this reaction. Someone tell me what is the answer for this A and B in this reaction. Identify the product in this reaction. What is the answer? Quickly, I have taught you this reaction in the previous classes. We have learned this reaction. Option D.
B.
Option B or D? Option
Sir,
D. No.
sir,
Anyways, now
option B, sir.
option B. All right. Rx, when it's allowed to react with silver cyanide. Now, what's that we get is, now this AgX gets eliminated as a byproduct. And now this is AgCN is having a partial covalent character. Since it has a partial covalent character, it gets bonded to R group through nitrogen. Therefore, we will get RNC, isocyanides. Now, same reaction, if we allow it to react with KCN, aqueous KCN. So what happens is K and X gets eliminated as KX. And in place of X, carbon gets bonded. So you get RCN. So this is nothing but cyanides. So in case of AgCN, you get isocyanides because cyanide can behave like an ambidentate nucleophile. So here it can behave like nitrogen as a donor atom. In case of KCN, carbon is behaving like a donor atom. This is called as nucleophilic substitution reaction. It's called as nucleophilic substitution reaction. So the product here is RCN. So hence the answer for this question will be what? What will be the answer for this question? Option
B.
Hey, option C. First is AgCN.
Yes, sir.
AgCN gives you what? NC. And
yes, sir.
KCN gives you what? CN. So
CN,
it's option
yes, sir. Option C.
Yeah. Don't get confused. It looks similar. So you should be careful when you're marking the answers. Otherwise, you'll lose marks. In the following sequence of reaction, the end product is, what is the following sequence of the reaction? The first one is CH3Br, and this is allowed to react with KCN. When this is allowed to react with KCN, what's that you get? K and Br gets eliminated as KBr. And in place of Br, what goes? Cyanide. So you get CH3CN. Now, what is this H3O plus called as? What is this H3O plus called as? This H3O plus is called as hydronium ion. What do you mean by hydronium ion? It is water and H plus. So H plus means it is acid. Now, dilute acid. Whenever you use dilute acid, what takes place is hydrolysis. What takes place is hydrolysis. What do you mean by hydrolysis? Hydrolysis means addition of water. Now this water, hydrolysis, water, I can write it as O and H2. One molecule of water, I can write it as O and H2. Second molecule of water, I'll write it as OH and H. Is it possible? H2O, here also H2O. Yes. If I divide this, what happens is, here oxygen and OH gets bonded to carbon. These hydrogen atoms gets bonded to nitrogen. So what gets eliminated? Ammonia gas gets eliminated as a byproduct. What is formed? CH3COOH. What is formed? Acetic acid, a carboxylic acid is formed. So option B is carboxylic acid. Option B is carboxylic acid. Here it's acetic acid and specific ethanoic acid. IUPAC name is ethanoic acid. This, when you allow it to react with lithium aluminum hydride in ether. This lithium aluminum hydride is a reducing agent. This lithium aluminum hydride is a reducing agent. It reduces carboxylic acid to alcohols. So lithium aluminum hydride reduces carboxylic acid to alcohols. See, acetic acid, I'm writing it like this. This, when you allow it to react with lithium aluminum hydride, it is a reducing agent, a strong reducing agent. What is a reducing agent? Which gives nascent hydrogen will be called as what? A reducing agent. When I say which gives a nascent hydrogen will be called as reducing agent. For this reaction, 1 mole of acetic acid will require 4 moles of nascent hydrogen. So that 4 moles of nitrogen, I can write it as 2H and 2H. So when I write 2H, what happens? 2 hydrogen and oxygen gets eliminated as water. In place of this oxygen, what goes? Hydrogen. So therefore, how many hydrogen? 2 hydrogen. Therefore, what do I have now? CH3, CH2, and OH. What will be this called as? This is called as ethanol. See, these kind of questions, the answer will be option D. These kind of questions, you will have to do it in 1 minute in your CET. All right, you will not have more time. So you should practice more of organic reactions. Organic reactions cannot be memorized. All right, you have to write and practice many number of times. Only then you'll be confident. Did you understand the sequence of this reaction?
Yes, sir.
Yeah. Practice more number of times. Only then you will understand. Right. The next question. Chloropicrin. Chloropicrin is obtained by the reaction of. Chloropicrin is obtained by the reaction of steam on carbon tetrachloride, nitric acid on chlorobenzene, chlorine on picric acid, nitric acid on chloroform. Now the answer for this question is option D, nitric acid on chloroform. What's the formula of chloroform? What's the
So CHCl3.
CHCl3. When the CHCl3 is allowed to react with nitric acid, HNO3, nitric acid. Now this nitric acid, I will write it as OH and NO2 for our understanding. So what happens here is this OH and this H gets eliminated as water. In place of H, what else is there to go? Because carbon should satisfy tetravalency, NO2 goes. So what I have now, C, NO2 and Cl thrice. This is called as nitrochloroform. Nitrochloroform. This nitrochloroform is called as chloropicrin. The common name for nitrochloroform is chloropicrin. Did you understand the reaction?
Yes, sir.
Yes, sir. Wonderful.
Yeah,
Sir.
please remember all these kind of questions now for competitive exams. Now the OH group of an alcohol or the COOH group of an carboxylic acid can be replaced by chlorine using PCl5, hypochlorous acid, chlorine, hydrochloric acid. See, the OH of an alcohol or a carboxylic acid can be replaced by chlorine using, what's the chlorinating agent they're asking? Now alcohol, if I take CH3, CH2 and OH, this is an alcohol. When this alcohol is allowed to react with PCl5, the bonds between oxygen and carbon breaks, and likewise the bond between oxygen and hydrogen also break. 5 chlorine atom is there. 1 chlorine atom reacts with H, gets eliminated as HCl. 1 more chlorine gets reacted to carbon, so you get ethyl chloride, CH3, CH2 and Cl, ethyl chloride, alkyl halide. And you have 3 more chlorines. Those 3 more chlorine along with phosphorus reacts with oxygen to form phosphoryl chloride, POCl3. Similarly, if you take a carboxylic acid, the specific example only we will write, carboxylic acid, COOH. When this is allowed to react with PCl5, the bond between carbon-oxygen breaks and the bond between oxygen-hydrogen also breaks. So 1 chlorine reacts with H and gets eliminated as HCl. 1 more chlorine reacts with carbon and it gets a product, CH3COCl. This is called as an acid chloride. The specific name is acetyl chloride. The common name is acid chloride, example for acid chloride. So what else is left out? Another phosphorus and 3 chlorine react with oxygen to form POCl3. Hence, the OH group of an alcohol and COH group of carboxylic acid can be replaced by option A, it is PCl5. I hope you followed with this reaction. The 6th question. When CH3, CH2, CHCl2 is treated with the soda amide, the product formed is what is the product formed? What is the product formed? I want you to tell me what is the property of NaNH2. I told you in the previous classes when we were learning, I told you this. What's the property of this? Now, what is the property of KOH, alcoholic KOH? What's the property of alcoholic KOH? This alcoholic KOH is called as dehydro.
So dehydrohalogenating agent, sir.
Oh, what do you mean by dehydrohalogenating agent? Removal of hydrogen
Yes,
and
sir. Hydrogen and
halogen
as well as the halogen, sir.
from the neighboring carbon atom, not from the same carbon atom, from the adjacent carbon. That's called as dehydrohalogenating agent. Here, soda amide is a strong dehydrohalogenating agent. Strong dehydrohalogenating agent. So KOH is normal, is a strong dehydrohalogenating agent. When we say soda amide is a stronger dehydrohalogenating agent, what will happen? You see CH3, CH2, CH, Cl, and Cl. This is this molecule. Now, when this is allowed to react with soda amide, dehydrohalogenation has to take place. This chlorine and this hydrogen gets eliminated. So therefore, what is that you get? You get CH3, CH, you have CH and Cl. Since chlorine and hydrogen is eliminated, what will be formed? A double bond will be formed. So alkyl chloride is formed. But further, this will not stop. The reaction will not stop because NaNH2 is a strong dehydrohalogenating agent. So what happens? This chlorine and this hydrogen gets eliminated as HCl. So what else you have? CH3, I have C, I have a double bond, and I have CH. But what happens? CH is there. Since chlorine and hydrogen is eliminated, what will be formed? A triple bond will be formed. So 1, 2, 3. The molecule name will be propyne. The answer for this question will be option. See, there's a triple bond here. Triple bond. So it will be option B, propyne.
B, sir. Option B.
Propyne. All right. Now, coming to the next question. CH3, CH2, Cl. It's allowed to react with sodium cyanide. It's allowed to react with sodium cyanide. You get X, and this is allowed to react with nickel in hydrogen. You get Y. Oh, excuse me. And this is further allowed to react with acetic anhydride. In the above sequence, Z is, see the complexity of the reactions. Now CH3, CH2, Cl. This is ethyl chloride. When this is allowed to react with sodium cyanide, what's that you get? Na and Cl gets eliminated as NaCl. In place of chlorine, cyanide goes. So you get CH3, CH2, and Cn. Now this is X. This is X. Now this is allowed to react with nickel in the presence of hydrogen gas. This is called as hydrogenation. Now, whenever nickel is used as a catalyst and hydrogen is used, the process is called as hydrogenation. What do you mean by hydrogenation? Addition of hydrogen will be called as hydrogenation. So what happens is, now we require 2 moles of this. So 2 hydrogen atom gets bonded to carbon and 2 hydrogen atom gets bonded to nitrogen. Therefore, the next product what we get is you get an amine, CH3, CH2, CH, one more CH2 you get, and you get NH2. It is a primary amine. You get primary amine. This, when you allow it to react with, this is Y. Now this, when you allow it to react with acetic anhydride. What is acetic anhydride? Now acetic anhydride is CH3, CO, and you have an oxygen, CO, CH3. CH3. What happens? You see, one of the hydrogen and this gets eliminated as acetic acid. The byproduct what you get is CH3COH, CH3COOH. In place of this H, what goes? This whole group goes. So what you get? You get CH3, CH2, CH2, you get NH, and what you have? CO, and you have CH3. So what will be the name? What will be the answer for this question? The answer for this question will be option A. Did you follow this reaction?
Yes, sir.
Yeah. Now coming to the next set of reactions, the reactivity order of halides for dehydrohalogenation. What is the reactivity order of halides for dehydrohalogenation? Now you should understand that as the atomic size increases, the bond strength decreases. The bond breaks easily. Now, if you take RF, RBr, alkyl fluoride, alkyl chloride, alkyl bromide, and alkyl iodide. See, iodine is a larger atom. Since iodine is a larger atom, what happens is bond length is more and bond strength is less. What do you mean the bond strength is less? Ri, this molecule can be easily what? Broken compared to all the other. So as you go down the halogen family, what happens? The bond strength decreases because the size increases. Therefore, the answer for this question will be reactivity order of halide for dehydrohalogen, which will be more reactive because this can be broken easily. And this means this will be more reactive compared to all other. So Ri will be more reactive compared to RBr. RBr will be more reactive compared to RCl, and RCl will be more reactive compared to RF. Hence, the answer for this question will be option B. The next question, an organic compound A, C4H9Cl, on reaction with sodium diethyl ether gives hydrocarbon, which on monochlorination gives only one chloro-derivative, then A is. What is that they're asking? We learned this in the theory part. If you remember, you should be in a position to answer. Now, C4H9Cl. Now, they're not named what is C4H9Cl. So I will try to write this C4H9Cl. This is tertiary butyl chloride. Now, this is a tertiary carbon atom. This is a primary carbon atom. This is a primary carbon atom. This is a primary carbon atom. This is a tertiary carbon atom. Now, this on reaction with sodium metal. When I say this is on reaction with sodium metal, you need to have one more alkyl halide group. So that is, I'm writing the same molecule like this. In the reverse order I'm writing. So what happens now? Na and Cl gets eliminated as NaCl. If you could remember, this is called as Woods reaction. We learned what is Woods reaction. So NaCl gets eliminated to NaCl. So what is that you get? The product what we get is you have CH3, CCH3, CH3, CCH3, CH3, and CH3. But just observe, all these are primary carbon atoms. All these are primary carbon atoms because all these are bonded to only one more carbon atom. Therefore, all these are primary carbon atoms. Since all these are primary carbon atoms, when you chlorinate this, you will get only one product, whether it is, it's a symmetric molecule again. So whether the substitution takes place here, or here, the product remains what? Only one. Because all these hydrogen atoms are identical. They behave same because it's all belonging to primary carbon atom. Hence, the answer for this question will be option A, tertiary butyl chloride. Followed?
Yes, sir.
Followed, sir.
We will learn two questions now. We'll finish off with the 10th question and then go for the next two question mechanisms. I didn't teach you the mechanism. We will learn the mechanism now and then We'll continue with the topic. This I'll finish up. Which of the following undergoes nucleophilic substitution reaction exclusively by SN1 mechanism? Exclusively by SN1 mechanism. The answer for this question is benzyl chloride. Benzyl chloride, benzyl carbocation, is more stable compared to propyl carbocation, and that is isopropyl carbocation, and that is more stable to ethyl carbocation. So therefore, the answer for this question will be benzyl carbocation. So you wouldn't have understood this, but anyways, we will learn the mechanisms and then come back to this. For again, we'll learn this. I'm looking out for space to write the mechanisms. I think I should be in a position to write here. I'll write here only. Now the mechanism, what we're going to learn will be called as SN1 mechanism and SN2 mechanism. Now what is this SN1 and SN2 mechanism? Now first we will write SN1 mechanism. Substitution, nucleophilic, unimolecular reaction. Substitution, nucleophilic, unimolecular reaction. That's called as what SN1 mechanism. Sometimes teachers will write like SN1 mechanism like this. So either ways you can represent this. SN1 mechanism stands for substitution nucleophilic unimolecular reaction. Now this SN1 mechanism will be undergone by tertiary alkyl halides more easily compared to secondary alkyl halide, compared to primary, compared to methyl. So tertiary alkyl halides will undergo SN1 mechanism more easily compared to the other alkyl halides. We will learn the reason later. Now, what is the overall reaction? The overall reaction is this. Tertiary alkyl halide. Now, we will take an example for example as tertiary butyl bromide. This tertiary butyl bromide, when it is allowed to react with a nucleophile like KOH or NaOH, KOH gives you what? K plus and OH minus. NaOH gives you what? Na plus and OH minus. Electron-rich group is called as nucleophile. Therefore, we have written OH minus as a nucleophile here. We get it from NaOH or KOH. What happens is this OH will displace bromine. Therefore, what happens? You get CH3, CH3, OH, and CH3. This will be called as tertiary butyl alcohol. This will be called as tertiary butyl alcohol. So what will be the overall reaction? The overall reaction is when tertiary butyl bromide is allowed to react with aqueous KOH or aqueous NaOH, nucleophilic substitution reaction takes place, forming tertiary butyl alcohol. Did you understand the overall reaction? What will be the statement you will write? The statement you will write is when tertiary butyl bromide is allowed to react with aqueous NaOH or aqueous KOH, nucleophilic substitution reaction takes place, forming tertiary butyl alcohol. Did you follow the overall reaction?
Yes, sir.
Now we'll learn
Yes.
the mechanism. In order to understand the mechanism, firstly, the mechanism takes place in two steps. The mechanism takes place in two steps. Now, the first step is, step one is generation of ionization of, okay, maybe we'll write like this, ionization of, it's a slow process, ionization of tertiary butyl bromide to form tertiary butyl carbocation. This is a slow process. This ionization is a slow process. It's a rate determining step. In a multi-step reaction, the slowest step of the reaction is called as a rate determining step. So ionization of tertiary butyl bromide to form tertiary butyl carbocation is a slow process. Now, what is happening here? Now this tertiary butyl bromide, CH3, CCH3, CH3, and Br, this will undergo ionization. Ionization is a slow process. When I say this will undergo ionization and it is a slow process, what happens is the bonded pair of electrons will be pulled towards bromine. When the bonded pair of electrons are pulled towards bromine, bromine will gain negative charge and carbon will gain positive charge. So what happens here is the bond between carbon and bromine breaks. Now, when the bond between carbon and bromine breaks, you get bromine to be a negative charge. And what happens is this carbon, and you have CH3, you have CH3, and you have CH3. It forms a planar molecule in the form of a circle. And this carbon gains positive charge. This is called as tertiary carbocation. It is called as tertiary carbocation. If you could see the cycle, at the center of the wheel, there's a rim, there's an axle and spokes. Likewise, this is an axle. This looks like an axle, and these are all like spokes of a wheel. So you get a circular planar molecule, and this is called as tertiary butyl carbocation. This is called as tertiary butyl carbocation. This process is a slow process. Now, since this carbon has a positive charge, it will be highly reactive. Now, when we say highly reactive, the second step is attack of nucleophile. Attack of nucleophile. Attack of nucleophile on carbocation. Now, when we say attack of nucleophile on carbocation, we can write like this. This is a carbocation, what we learned now, the first step. And what happens is OH minus, nucleophile being more reactive, it will attack the carbocation. When it attacks the carbocation, you get CH3, 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 and you get OH. It is called as tertiary butyl alcohol. It's called as tertiary butyl alcohol. Now, this reaction rate is directly proportional to concentration of tertiary butyl bromide only, because the second step of the reaction is a fast reaction. So in the first step, we have only one molecule taking part. Therefore, rate of reaction depends only on the concentration of tertiary butyl bromide. Therefore, we say the order of the reaction will be 1 and molecularity of this reaction is 2. So this is about SN1 mechanism. Just go through this SN1 mechanism, step 1 and step 2. The first step of the reaction is generation of electrophile. Electrophiles are generated by ionization of alkyl bromides. When alkyl bromides, tertiary butyl bromide in specific, when it undergoes ionization, it leads to the formation of tertiary butyl carbocation. This tertiary butyl carbocation being more reactive, it reacts with nucleophile to form tertiary butyl alcohol. Understood? Go through this reaction and tell me if you have any clarification. It's an important question for 12th standard.
No, sir, not also.
Others followed?
Yes, sir.
Yeah. Now we will learn SN2 mechanism. I'll erase this and I will work the SN2 mechanism here itself. Right. So just give me some time. All right, we'll do it some other place. We'll do it here. Now this SN2 mechanism, it is substitution nucleophilic bimolecular reaction. Molecularity will be 2 here, therefore it's called as a bimolecular reaction. Now, primary alkyl halides will undergo more easily SN1 mechanism, SN2 mechanism, primary alkyl halides. Primary alkyl halides will be more easily. So primary will be greater than secondary, secondary will be greater than tertiary. And firstly, you should say methyl is greater than what? Primary alkyl halide. Methyl groups will undergo more easily SN2 mechanism compared to primary to secondary and secondary to tertiary. Now, what is the overall reaction? The overall reaction is, now if you take a molecule like this, methyl bromide, when this methyl bromide is allowed to react with aqueous NaOH or KOH, what happens is OH will be substituted for Br. So therefore you get OH plus Br minus. So you get primary alcohol. In case of SN2 mechanism, you get tertiary alcohol, tertiary butyl alcohol. And in case of SN2 mechanism, you will get primary alcohol. Now, when we say primary alcohol, how is this mechanism? Now, methyl bromide, now I'm writing the mechanism here. This methyl bromide, carbon is tetravalent. When you say carbon is tetravalent, it is undergoing, or the shape of the molecule will be tetrahedral. The geometry of methyl bromide is tetrahedral because carbon is undergoing sp3 hybridization. Therefore, the geometry will be tetrahedral. When this is allowed to react with OH minus, what happens is this OH minus attacks the carbon atom from the rear side, from the back side, from the opposite side of the halogen, from the opposite side of bromine. So what happens that time? We get a transition state. We get a transition because carbon can have only 4 bonds. Carbon cannot have 5 bonds. So when OH starts forming a bond with carbon, the bond between carbon and bromine starts breaking. That's why we have written a broken line. And this state is called as transition state. It is called as what state? Transition state. Once the OH bond is completely formed between carbon, the bond between carbon and bromine completely breaks. So what you get is you get H, 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 and you get OH, and you get Br minus. So this will be called as methanol. This will be called as methanol. Now, if you observe in here, the structure, the halogens on the right-hand side, the substituted product, if you see, the OH on the left-hand side. So the configuration is completely changed. This kind of configuration is called as Walden inversion. This kind of configuration is called as Walden inversion, W-A-L-D-E-N, Walden inversion. Now for this SN2 mechanism, the rate of a reaction depends both on the concentration of alkyl halide and the concentration of the nucleophile. So this is a one-step reaction. It is not a two-step reaction. So when the nucleophile attacks the carbon from the opposite side to the halogen, bond between OH and carbon starts forming, and the bond between carbon and bromine starts breaking. You can see there's a strong bond here, but when OH attacks, the bond starts breaking. Once the OH group completely gets bonded to carbon, what happens? The bond between carbon and bromine completely breaks to form an alcohol, primary alcohol. Methanol is an example for primary alcohol. Did you understand? And Walden in the inversion is shown only by SN2 mechanism. Walden inversion is not shown by SN1 mechanism. Followed?
Yes, sir.
Clarification with these two mechanisms. It will be a regular question. The difference between SN1 and SN2 mechanism, if they ask you, you should tell SN1 and SN2. In case of SN1, the molecularity is unimolecular. In case of SN2, molecularity is a bimolecular. SN1 takes place in how many steps? SN1 takes place in how many steps?
2 steps, sir.
So 2 steps.
2 steps. See, this is SN1 and SN2 difference. Now this is, this is unimolecular. This is bimolecular. Here 2 steps. Here it is 1 step. Third point, tertiary alkyl halide is more easily undergoing SN1 compared to secondary, compared to primary and methyl. And here SN2, methyl group will undergo easily compared to primary, compared to secondary, and compared to tertiary. Right? Here, mild nucleophile, fourth difference, mild nucleophile. Here, you need to have a strong nucleophile. So these are the four differences between SN1, and I didn't mention, SN1 takes place in how many steps? 2 steps. And SN1 takes place in 2 steps. And the fifth difference, SN1 takes place in 1 step. So these 5 differences you can remember to answer some of the questions if they ask. They can ask you SN1 mechanism, SN2 mechanism, or they can ask you difference between SN1 and SN2 mechanism. There are differences they can ask you for 2 marks. So please remember, SN1 is a unimolecular reaction, SN2 is a bimolecular reaction, I've written here, SN1 takes place in 2 steps and SN2 takes place in 1 step. And for SN1 tertiary, secondary, order is this. Tertiary is more easily undergoing SN1 mechanism. And SN2, when we say methyl group, will undergo more easily. And mild nucleophile is enough for SN1 and strong nucleophile for SN2. Clear with these 2 mechanisms?
Yes, sir.
Now, we will learn some of the questions and then we will stop. Maybe another 3-4 questions we will see and then we will stop. Now you should tell me the 11th question. In SN2 substitution reaction of type RBr plus Cl in DMF, RCl and Br minus, which one of the following has highest relative rate? R is an alkyl. Which one has the relative rate? This is SN2 mechanism. Now, when I say SN2 mechanism, methyl, primary, secondary, and tertiary. This is primary. This also is primary, right? This also is primary, and this also is primary. All halogens are primary. So what will be the answer for this? What will be the answer for this? Methyl group is stronger than primary, and it is stronger than secondary and tertiary. So answer for this. However, all are primary alkyl halide. In this case, since all are primary alkyl halide, the nucleophile is sterically hindered. The nucleophile will have difficult to getting the backside of the alpha carbon atom. As a result of this, elimination product will be predominant. Hence, CH3CH2Br is least hindered. Hence, it has higher relative rate towards SN2 mechanism. Now, if you observe, all these are bulky groups. Now, when all these are bulky groups, the OH group has to attack from the backside. When the OH group has to attack from the backside, what happens? Steric hindrance will take place. Due to steric hindrance, the rate of the reaction becomes slower. But in case the minimum steric hindrance is shown by this CH3CH2Br group, hence this will show highest relative rate, highest speed will be shown by option D. Did you follow this?
Yes, sir.
The next question, butane nitrile can be prepared by heating. Butane nitrile. What are nitriles? Cyanides are called as nitriles. Butane nitriles can be prepared by heating. How do I prepare, or how can we prepare butane nitrile? Now, if you take a molecule like this, butane nitrile should have 4 carbon atoms. So if butane nitrile should have 4 carbon atoms, I cannot take the reagent which has 4 carbon atoms already. So option B and option C is ruled out. Now, this should be propyl alcohol and propyl chloride. You cannot react alcohol with cyanide. So this also is ruled out. So if you take propyl chloride, when this is allowed to react with potassium cyanide, what happens? K and Cl gets eliminated as KCl. In place of Cl, what goes? Cyanide goes. Therefore, what you get? You get CH3, CH2, CH2, and Cn. This will be called as butane nitrile. 4 carbon atom but, carbon to carbon, single bond butane, but it contains a cyanide. Therefore, it is called as butane nitrile. Hence, the answer for this question will be option D. The next question, ethyl alcohol is obtained when ethyl chloride is heated with. When ethyl chloride is heated with, what will be the answer? Alcoholic KOH, aqueous KOH, water, aqueous potassium permanganate. What will be the answer? Ethyl alcohol is obtained when ethyl chloride as a formula. When this is allowed to react with aqueous potassium hydroxide. See, alcoholic potassium hydroxide will undergo dehydrohalogenation. Now, aqueous potassium hydroxide will undergo nucleophilic substitution reaction. So you should know the difference. Now, K and Cl gets eliminated as KCl. In place of Cl, what goes? OH. Therefore, you get CH3, H, and you get OH. This is ethanol. This is ethanol. It is called as nucleophilic substitution reaction. So aqueous KOH, when we use, the reaction will be nucleophilic. When we use alcoholic potassium hydroxide, it will be dehydrohalogenation. The next question, alkyl halide is converted into alcohol by elimination, dehydrohalogenation, addition, or substitution. Now you tell me this reaction only we did previous. What is this reaction? What is this reaction I was telling? So this is an alkyl halide.
So dehydrohalogenation.
No, aqueous KOH. When I use alcoholic KOH, is dehydrohalogenation. It's called as
Elimination, sir.
no. It's called as
So
nucleophilic substitution reaction. In place of Cl, what has been substituted? OH. Therefore, specifically it is called as nucleophilic substitution reaction. So here they've given just only substitution. Therefore, the answer for this question will be option D. The next question. Tertiary alkyl halides are particularly inert to SN2 mechanism. See, SN2 mechanism is undergone easily by what group? Methyl group, followed by primary, followed by secondary, and tertiary is the least. Why tertiary alkyl halides are particularly inert? See, tertiary alkyl halides are big molecules. So the OH group to attack the carbon atom from the rear side, from the back side, becomes difficult. That is called as steric hindrance. So tertiary alkyl halides are particularly inert to substitution by SN2 mechanism because of steric hindrance. Therefore, the answer for this question is option B. Today we have learned a few of the concepts, and also we learned two mechanisms, SN1 and SN2 mechanism, difference between SN1 and SN2 mechanism. I hope that you followed with so many questions, around 15-20 questions we learned, the competitive based questions. I hope that you follow. We'll continue with the class maybe possibly next week. We'll start with some of the questions and then continue with some of the reactions again, different reactions we'll learn. All right, ma'am, I'll stop the class, ma'am.